China has launched an ambitious mission to study two intriguing objects in our solar system, the likes of which have never been visited by a spacecraft before. The Tianwen-2 mission launched aboard a Long March 3B rocket from the Xichang Satellite Launch Center in Sichuan province at 1:31 p.m. ET on Wednesday, 1:31 a.m. Thursday local time in China, according to the China National Space Administration. Like Tianwen-1, which lifted off in July 2020. With two aims, delivering an orbiter and a rover to Mars. Tianwen-2 has two goals. The mission's initial goal is to fly by and collect the country's first samples from an asteroid. The space rock, called Kamoʻoalewa, or asteroid 2016 H03, may be a chunk chipped off the moon, which has become a quasi-satellite near our planet. The spacecraft will spend 1 year flying to the asteroid and another year orbiting and assessing potential landing sites after dropping off those samples at Earth via a capsule. About 2 years from now, the mission will then take 7 years to reach an unusual object called Main Belt Comet 311P Pan-STARRS and conduct a flyby. Sometimes referred to as an active asteroid, the celestial object orbits between Mars and Jupiter and produces dusty, comet-like tails. Both Kamoʻoalewa and 311P Pan-STARRS are incredibly interesting targets that stem from populations of objects that, up until a couple of years ago, astronomers barely knew existed, said Dr. Teddy Kurita, a postdoctoral associate of planetary science at Lowell Observatory in Flagstaff, Arizona. Now we get to study them up close in a kind of detail that will really revolutionize our understanding of them and objects like them, Kurita said in an email. Plus, anytime we see a new kind of solar system object for the first time with a spacecraft, it's like opening presents on your birthday. Whatever's underneath the wrapping paper. It's always exciting to see something for the first time, and to try to do your best to understand it. A risky sampling effort. Astronomers first discovered Kamoʻoalewa in 2016 using the Panoramic Survey Telescope and Rapid Response System, or Pan-STARRS, telescope in Hawaii. Ben Sharkey, now a visiting senior faculty specialist at the University of Maryland, College Park, led a study published in November 2021, suggesting that the Ferris wheel-size asteroid may be a massive boulder. Ejected from the moon by an impact, the name Kamoʻoalewa comes from a Hawaiian creation chant that alludes to an offspring traveling on its own. It will be the smallest asteroid ever visited, measuring between 150 and 190 feet, 46 and 58 meters in diameter, said Dr. Patrick Michel, Director of Research Exceptional, class at the French National Center for Scientific Research. Michel also served as a co-investigator on missions by NASA and the Japan Aerospace Exploration Agency, OSIRIS-REx and Hayabusa 2, respectively, that returned asteroid samples to Earth. Bennu, the asteroid sampled by OSIRIS-REx, had a diameter similar to the height of the Empire State Building, or 1,614 feet, 492 meters. Kamoʻoalewa is a quasi-satellite, a type of near-Earth asteroid that orbits the Sun but sticks close to Earth, coming within about 9 million miles. 14.5 million kilometers of our planet, until Ben Sharkey saw that it reflected light like the moon. We didn't think there were chunks of the moon out in near-Earth space, Kurita said. The moon's covered in craters. But who knew that the violent formation of those craters might toss tennis court-sized rocks seemingly intact that we could find and study thousands or millions of years later? Studying and sampling, Kamoʻoalewa could help astronomers determine whether the space rock actually originated from the moon or if it just reflects light similarly, Kurita said. Kurita is also involved with a study led by Sharkey that will use the James Webb Space Telescope to study Kamoʻoalewa in more detail next year. If it's actually from the moon, then we might be able to identify other lunar samples that have similar properties and help to get an idea of where it came from on the lunar surface, Kurita said. If it just looks like the moon but is actually from somewhere else, the sample will facilitate a radically more informed search for where Kamoʻoalewa actually came from. The mission could also shed light on asteroids that can cause damage if they were to strike Earth. Kamoʻoalewa is comparable in size to the object that devastated Tunguska in Siberia over a century ago, Michel said. A roughly 98-foot wide, 30-meter wide asteroid struck the Podkamennaya Tunguska River in a remote Siberian forest of Russia in 1908, according to the Planetary Society. The event leveled trees and destroyed forests across 830 square miles, 2,150 square kilometers, Orbiting and landing on such a small body is complicated, which is part of what makes the mission both interesting and risky, Michel said. To get into orbit, you really have to get very close, and even if you just follow it, the maneuvers remain very sensitive because there's really very little gravity and its rapid rotation forgives no mistakes, Michel said. Plus, the plan is to get a sample, so there are not many areas where the probe can land safely. Following a dusty comet, the space rock 311P Pan-STARRS is one of the best-studied active asteroids, Kamoʻoalewa said. Even just 25 years ago, we didn't know there were active asteroids at all. Scientists thought that only icy comets from the outer solar system could produce comet-like tails, but it turns out that a couple of dozen asteroids do so as well, without much or any ice involved, Kamoʻoalewa said. Astronomers have come up with a number of hypotheses for why the object is throwing off dust, including posing the existence of pressure pockets that eject material and the idea that other objects could be impacting 311P Pan-STARRS and releasing elements, Michel said. Flying by the active asteroid could show exactly what processes are creating the dusty tails streaming from the object and might reveal possibilities scientists haven't even considered, Kamoʻoalewa said. This will be the first time such an object is observed up close, and we can determine which mechanism, there may be others, drives the activity, Michel said. The data gathered by Tianwen-2 could enhance a wide range of studies of objects within the inner solar system, which includes Mercury, Venus, Earth, Mars, and the asteroid belt, Kamoʻoalewa said. There's a tremendous amount we don't know about either object, Kamoʻoalewa said. I don't think any spacecraft has ever gotten to its target and not found at least a few big surprises. I'm sure some of our current understanding for either object is completely wrong, and I'm excited to see how. Like and subscribe for more.